For this next section, we're going to deal with logs. So you might be wondering what logs are. That's quite easy. Think of it as when you square something and when you square root something, those are now the inverse functions of each other. Now we know of raising something to a power, so we're dealing with, let's say, x to the exponent of b. So that's raising the power of x to b. So let's say like if b was a variable, how do you then bring that exponent down or that variable down so you can solve for it? That's where logs come in. So if x to the power of b is equal to c, how do we then find b? If b were to be a variable, then we use the logarithm, right? So then logarithm is going to be, b will give us the log. Remember now base stays the same, so it's going to be log of base x of c. So then if we have x to the power of b is equal to c, how would we solve for b? We then say simply b is equal to log base x of c. To give you a quick example of that, if I had said 2 to the power of x is equal to 1024, how do we then find x? Simply say, therefore, x is equal to log base 2 of 1024, and then if you use that in the calculator, you'll get your answer for x. Okay, now let's go through some of the log laws that we have. Let me quickly just erase this board. Okay, now if we're going to look now at some of the laws that we use logs, right? Sorry. Okay, now let's look at some of the log laws that we have that we can use to help us solve problems. And I mean, people wonder, where do logs come in? We normally use a lot of logs in sequence and series, use some logs in financial maths. Any place where you need to bring an exponent down as a variable and try to solve for that exponent, you would have to use logs. So the first log law is, if I were to have now log base a of b plus, that's a very bad plus, sorry, plus log base a of c, that comes down nicely, and then that becomes log base a of b times c. Quite similar to what we did in exponents, just a bit sort of inverted like that. The next log law we can have is now one of minusing one from the other. So if we had log base a of b minus log base a of c, that will simply give us my log base a of b divided by c. Simple enough. The next one is if we have exponents now with logs. So now if I had to have log base a of b to the power of c, right? So if the exponent's on what you've taken the logarithm of, you can take that exponent and bring it right there in the front. So that's equal to c times, put that as a proper times there, log base a of b. This is a very, very, very important one that comes up quite a few times and people never know what to do when they get to that point there. The next one we can deal with is now log base a, right, of, let's say, a, and that's going to give us 1. So if you have log base something of the exact same number, that will then give us 1. The next thing we have, and which is the last one, if we have log base a of, let's say, 1, that will give us 0. Okay, so like this here, if we do like log base 2 of 2, that will be 1, right? And then if we had log base 3 of 1, that becomes 0, right? And let's think of this in another way, right? Remember, like I said, the logs are the inverse function for exponents. So if we had an exponential function, y is equal to, let's say, 2 to the power of x. That's a function that sort of does that. It crosses my y-axis at 1, and it's asymptotic to the x-axis, right? So now, if I'm saying, at what x value will my y value be 1, and this says, when my y value is 1, my x value will be 0, right? And so on and so on. So this is quite a nice, nifty little function that we deal with in algebra, the log. It helps us solve for a whole bunch of things when we're trying to solve for our exponents and make things make tons more sense with all the sections. Okay, let's try a couple of examples and see how we do with those. Express this in exponential form. So we get given 5 is equal to log base 7 of 16807. And that's pretty easy. Like I said before, all we need to do is remember that. Now, the main part of the log becomes the answer, base remains the same, and that becomes now our exponent. So then, base remains the same, so 7 to the power of our answer, right? So 7 to the power of 5 is equal to that whole answer there, 16807. Simple enough, nothing too crazy. Okay, let's try another one. The next one just says, let's solve for x without a calculator. Okay, so now number 2, to solve for x, we've got log base 22 of x is equal to 0. There's two ways to go about this one. We can look at our log laws and say, well, log of base anything to 1 would give us 0, right? Or we can actually try to solve it a different way. So let me show you how first to put this in exponential form and then evaluate it there. So in exponential form, this becomes 22 to the power of 0 equals x. And then using our exponent laws, you know that, well, anything to the power of 0 equals 1. Therefore, x equals 1. So you can either go exponential form, use exponent laws, or use log laws and apply the log laws like that. Let's do one last one. So my last example, we have log base 2 of x is equal to 8. Now again, that one we can't just easily evaluate it without a calculator using log laws. What we can do is take it back to exponential form, and that way we can see what needs to be. So then again, same thing, base remains the same, 2, our answer becomes exponent to the power of 8 equals, then the x over there. 2 to the power of 8 equals x. And then what do we need to do then? And say, well, what's 2 to the power of 8? We're going to say, well, 2 is 2 times 2 is 4 times 2 is 8, 16, 32, 64, 128, and then the 8th one is 256. So x equals 256. And it's as simple as that. So logs aren't that difficult. All it is that it's a means to an end when we use this in our financial maths, in our sequences series. And then the biggest part where we actually get to do logs is when we do inverse functions, and we learn about now the inverse of the exponential function, and we get really deep into logarithmic functions. But don't worry about that too much right now. As long as you get this, you should be good, and then I'll see you in the next session.